For this lesson, we're going to look at slope of similar triangles. So let's take a look at the first example, or the first method for calculating slope of similar triangles. What we have here, we're going to use the rise over run formula. First, we need to identify the 2 points for the first triangle. Then we're going to label and set up with letters for rise side over run side. So over here on this example, we have triangle KLM and triangle PRS. They're similar. Which proportion can be used to show that the slope of KM is equal to the slope of PS? So you're going to actually set this up yourself before looking at the answer choices. Follow the steps that I have there on the side. So the first thing, I'm going to label I'm going to put an S. This will be my small triangle. This will be my big triangle. Okay, so for my small triangle, I'm going to do the rise over the run. And so I look here, what is my rise? It shows that my rise is KL. So I'm going to put KL for my rise. KL over my run, which will be LM. So then I'll write that down. LM. That's for the small figure. And then I'm going to do the same for the bigger picture. So let's see, if I label, I've got my big, it's going to be rise over run again. Well, maybe I don't need to write all of that extra. I have it written over there on the left side, sorry. Okay, so I'm going to look for my rise side of my big picture. My rise side is PR, so then I'll label PR over the run of the bigger triangle, which will be RS. So that'll be RS. These are supposed to equal each other. So now we look at each of the answer choices. Well, looking at all of my setups, I need KL to be at the top of one of the two fractions. It doesn't matter if it's on the left side or the right side, but the KL needs to be at the top. Okay, so I look through and I'm like, oh, there's KL. I look here, I don't see KL at any top, so that's just out. Same thing on this one, I look at the tops, there's no KL. And on the bottom one, there's no KL. So let me just confirm with the other parts. Below the KL, I should have LM. Oh, I do. Then on the other fraction, I should have PR at the top. PR at the top, RS at the bottom, RS at the bottom. So my correct setup is answer choice A. Now if I see over here in the steps, so we did the labeling of the small picture, the rise over run, and we found our answer. But then this last part says the slope for both triangles should be equal. Well, if we work out the second part of each of these steps where it says to calculate the slope, we're going to calculate the slopes for each of these. So let me go ahead and just zoom closer so I can show you how it is true that these slopes are actually the same. So if I go on my small triangle, I'm going to do KL. So KL is, maybe I need to zoom a little bit more. So here, KL is rise 1, 2, 3, 4, -4. And I'm going to run. That looks like they're halfway, so that's about two halves in the middle there. So then I'm going to do the same with my big triangle. So let's see, from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So -12. And RS is 1, 2, 3, 4, 5, 6. And if you were to actually simplify each of these fractions, we would end up with, let's see, this simplifies to equal -2, this simplifies to equal 1, over here this equals -2 over 1, so both of them, -2 equals -2. The slopes are the same. Okay, so that's how you can find the slope of similar triangles, the setup for the slope of similar triangles using the rise over run method.